Hello everyone, my name is Anna, and today I will be explaining a project that I recently developed for my end of degree project. So, the purpose of this project was to design and implement a device coupled with a graphical interface for supporting mobility and preperception recovery in patients with cervical problems. Regarding the design of the device, the instruments that we used were an Arduino Uno microcontroller board, an Arduino ProtoShield Rev 3, and also an MPU 6050 sensor. We also developed an application in Arduino for the acquisition and captioning of the data. This device is supposed to be placed on the head of the patient by the help of an adjustable and elastic band. Regarding the sensor that we used, as I said, it was an MPU 6050. This is an IMU with 6 degrees of freedom that integrates a 3-axis accelerometer and a 3-axis gyroscope. Based on which angle the angular rotation will be applied, we have three different modes: roll, pitch, and yaw. In the first image, we can observe the model pinout of the sensor, and in the second one, it is observed the connections necessary for interfacing the Arduino with the sensor. Now, regarding the design of the graphical user interface, a purpose of a graphical interface is to facilitate the human interaction with a device's underlying code. For creating our graphical interface, we use the TekaInter library, which is the standard library in Python for creating this kind of interfaces. We also developed an executable file so that the final user could be able to access this graphical interface only by clicking this file and without having to execute the Python code behind it. Let's analyze the stages that were followed for creating our interface. We first created the root window and gave it a specific dimension and a title, which was Chrome Measurements. Then we created the necessary buttons. The first three of them were for representing the motion that a patient can realize while performing one of the three main movements. The first button was for the lateral flexion movement, the second one for the flexion extension, and the last one for the rotation. The next two buttons are for connecting and disconnecting the device. And lastly, the record and save button have the following functionality. When the record button is clicked, all the data that is being acquired by the sensor will be recorded. And when the save button is clicked, all the data recorded can be saved in a CSV or an Excel file. The user can choose a directory where he wants to store that file. We also created a graph where the depicted variables are represented. The first time the interface is initiated, all three plots will be depicted at the same time. Should our analysis focus only on a specific movement, we can deselect the previous two buttons and leave selected only the button we're interested in. We also added a functionality of a message appearing every time the device was connected or disconnected. And lastly, a logo for the interface. Now, a video will be displayed in order to show the general functionality of the interface. We first connect the device, and all three plots are depicted at the same time. First, we're interested in the lateral flexion movement, which is the one represented by our participant, so we leave only that button selected. Now, for the flexion extension movement, the one performed by our participant, we deselect the first button and leave selected the button for that movement. We'll follow the same procedure for the rotation exercise, the one performed by our participant, and we'll leave selected only the button called rotation. We'll disconnect now the device and connect it one more time in order to show the functionality of the record button. So we connect it one more time, we click this record button, and now all the data that the sensor is acquiring is being recorded. Our participant is performing several movements for this purpose. And once the save button will be clicked, all this data will be saved in a CSV or an Excel file. We can choose where the directory where we want to store this file. And if we open it, we'll see all the angles that the patient acquired while realizing each one of the movements, as you can observe here. It is important to mention that our sensor captures 5 measurements per second. The medical aspect around which our project was centered were the cervical spine disorders, which encompass issues related to the neck bones. The primary indication for these pathologies is the neck pain. One of the simplest assessments a physiotherapist can do is to see what movements can and cannot be performed by a patient. This is known as the cervical range of motion test, and it is assessed with the following three exercises: flexion extension, lateral flexion, and lastly, rotation. Among all the conclusions that we reached after the development of the project, the most important one would be that the introduction of a precise and user friendly device coupled with an intuitive interface has the potential to advance cervical mobility assessment practices. Thank you very much for your attention. This has been all for the video, and I really hope you enjoyed it.